Hello, good morning out there to you, wherever you're in the world. This is Samuel, and I can welcome you to this channel. So, in this lesson, we'll be looking at a topic called sorts. Sorts can fall under mathematics, further mathematics, additional mathematics. So, we're going to take sorts from the basis, and we're going to move on to more complex sorts. So, in this lesson, we're going to look at sorts. We'll start with the rules of sorts. So, and progress along. So we're happy that you've joined us for this lesson this morning. But in case you're not subscribed to this morning, I would like you to take a step and hit the subscription button and hit the like button, because definitely you're going to enjoy this lesson. And at the end of the day, make sure you drop your comment. So like I said, we're going to start sorts. So sorts, examples of sorts are something of this nature. Root 3. This is square root of 3, this is square root of 5, this is square root of 7. But when we are addressing, we're not going to call it square root, we're going to call it root 3, root 5, root 7. Root 3, root 5, root 7. For instance, root 4. Root 4 is the same thing as 4 is 2 times 2. So when you have these two pairs, the square root of 4, or you can break down 4 into two similar pairs, then definitely the square root of 4 will give you what? 2. But root 3, you can't break down root 3, you can't break down root 5, you can't break down root 7. This cannot be broken down. So you can actually leave it this way as root 3. So these are examples of sorts. They are irrational numbers. Irrational numbers. If you find the square root of 3, it's not going to terminate. It will never terminate. You will keep on having 1 point something. The same with 5, the same with 7. So we're going to look at the rules of sorts. So the first rule of sorts is that we're going to look at. So the first rule of sorts is that root a times b is equals to root a times root b. When you have two or more numbers under a sort, under the root sign, you can actually separate them to this form. So for instance, if you have root 9 times root, if you have root 9 times 4, you can actually separate them as root 9 times root 4. At the end of the day, this is going to give you 3. Root 9, square root of 9 is 3, and square root of 4 is 2. So 3 times 2 gives you 6 at the end of the day. If you have more than 2, root 9 times 4 times root 16, you can still separate this into root 9 times root 4 times root 16, and then you can go ahead and simplify. We know that root 9 is 3, root 4 is 2, root 16 is 4, and you now multiply them together. So that is just rule 1. That is rule 1. Okay, so root a times b can be separated into root a times root b. So that is law 1. So we're going to go to rule 2. So for rule 2 states that if you have root a over b, if you have a root a over root b, this can be separated into root a all over root b, such that if you have root 144 over
root 100. This can be separated into root 144 over root 100. Square root of 144 is 12. Square root of 100 is 10. And you can go ahead and simplify further. So this is rule 2. So we have rule 1, we have rule 2. Rule 2 has to do with multiplication under the same roots, can be splitted. Rule 2 has to do with division under the same roots, can also be separated. So we're going to move to our next rule. So for our next rule, take note that root a plus b is not equals to root a plus root b. When you have addition under a root sign, you can't split them. And the same thing also occurs for when you have division. Root a minus b is not equals to root a minus root b. Take note of that. Take note of that. So from here, we're going to move to basic forms. Basic forms. Basic forms. We're going to move to basic forms. Okay. So what is basic forms? For instance, right now, we have root 162. So root 162. Let's look at 162. We want to use a factor method to break down 162. So looking at 162 right now, 162 is even, so that means 2 can go in 162. So 2 in 116 is what? 8. 2 in 2, 1. Now looking at 81, if you look at 81, what can break that 81? Is there two numbers that can, when multiplied together, can give us 81? Yes, 9. 9 times 9 is 81. So we can just put 9 here. 9 in 81, 9. 9 in 9, 1. So we could have just, we know that 162 is 2 times 81. 2 times 81. 2 times 162 is, so we just come here, 2 times 81, and we apply rule 1, we now separate them. This is going to be root 2 times root 81. Root 2 times root 81. 2 times 81 gives us 162. Because if you divide 2 in 16, 8. 2 in 2, 1. 2 times 81 will land you on 162. So 81 is what? 9 times 9. So the square root of 9 times 9 of 81 is what? 9. The square root of 2 is going to be in decimal, so we're going to leave it this way. So we can take this 9 behind the root sign. We can write this as 9 root 2. So we can't simplify root 2 any further. This is the basic form of root 162. This is the basic form of root 164 or root 162. This is the basic form of what? Root 162. This is the basic form of root 162. So I'm going to do it again using another method so that you can choose the one that it's easy for you to understand. So I want to go from 162, root 162, and write this in the basic form. So what I'm going to use a factor method. we have 162. 162 is even, so that means 2 can go in it. 2 in 16 is 8. 2 in 2 is 1. 81. 2 can't go in 81 anymore because it's odd now. Can 3 go in it? Let's check. How do we know if 3 can divide a number? If the sum of the digits is divisible by 3, that means 3 can actually go. So let's test. 8 plus 1 for 81. 8 plus 1 is 9, and 9 is divisible by 3. So that means 81 can be divided by 3. So we use 3 now. 3 in 8. How many times can 3 go in 8? 3 can go in 8. 2 times. Remainder 2 times. So that remainder 2, you combine it with this one, giving you 21. So 3 in 21. 3 times 1 will give you 21. 3 times 7. So 3 in 21 is 7. Now 27. 3 can go in 27. 3 in 27 is 9. 3 times 1, 3. 3 times 9, 27. 3 times 9 is 27. Now 3 can go in 3. And 3 times 3 is 9. So 3 times can go in 9. 3 times. Now, the only thing that can go in 3 is 3. So 3 in 3 is 1. So we can rewrite 162. This 162 as 2. 162 is equals to 2 times 3 times 3 times 3 times 3. So we can write 162 as 2 times 3 times 3 times 3 times 3. So now we're going to pair them in twos. Like any number that has a twin, you're going to put them in bracket. Like 2 is alone, we're going to leave this 2. So this one, we pair them. We pair these 2. Okay? So having paired them right now, next, we are going to separate them. So we're going to have 2 times root 3 times 3 times root 3 times 3. We separate it 2. We separate this pair. We separate this pair. So these ones are a pair. The rule of square root, if you are finding square root, once you can pair 2 numbers, you pick one of them. So the square root will disappear. So from here, we pick one of the 3. From here, we pick one of the 3. From here, we have just 1, 2. So this will still remain this way. So at the end of the day, you have 3 times 3, which is 9 root 2. So you can actually bring this 9 behind the root and write this as 9 root 2. So the basic form of root 162 is what? 9 root 2. Okay, so we'll take 1 or 2 more examples before we'll close up on basic form of surds. So I believe this is understood. So we use a factor method to break down the numbers into factors, and then we now pair them, the one that have pairs. Okay, so we'll take another example. So before we move on, if you know you're not subscribed, just go ahead and hit the subscribe button and hit the like button as well, and at the end drop your comment. Thank you. So we want to write root 54 in its basic form. So just like I said before, 54 using the factor method, since 54 is even, 2 can break it down. So you have 2 in 5, 2. 2 in 5 gives you a remainder of 1. So you combine that with the next number, which is 4, giving you 14. 2 in 14 is 7. 3 in 20, 3 can go in 27 9 times. 3 can go in 9 3 times. 3 can go in 3 once. So this can be written as 2 times 3 times 3 times 3. Okay, so we go ahead and next we look for whether they are pairs. There are actually pairs that, yeah, this is paired, so we pair that one. This 3 doesn't have a pair, this 2 doesn't have a pair. So what are we going to do to them? We can combine them, merge them into one number. So you're going to have 6, then times this pair of 3s. Then you can, next you separate them. You separate the 6 under different root sign, applying rule 1. So these 2 that have a pair, actually you can just pick one of them and the root sign, this square root sign will disappear. So this gives you 3 times root 6. So the 3 can go behind the root sign. We're giving you 3 root 6. So that is the final answer for root 54. Okay. So the next one, we'll take our last example right now. So our last example for finding the basic form of a sword, we're going to use root 200. So here we are going to use a slightly different approach. We know that 200 is even, so 2 can break it down. 2 can break it down to, if 2 goes in 2 in 2, this is 1, this 2 in 0 0, 2 in 0 0, this gives you 100. So 100 can be written as 2 times 100. And you can use a factor method if you want to, but I just want to use another method because I know that 10 times 10 gives me 100. So why waste my time using that factor method? It's not compulsory you must use the factor method if you actually can split the number directly into 2 numbers that you know you can actually break down further without giving you stress. So 2 times 100 is 2 times 100 is 200. So we know 100 is 10 times 10. So we write this as, we split it down into root 2 times root 100. Okay, so now root 100 is 10 times 10. So from there, from here, what do? You pick up just 110. So you have root 2 times 10. Next, you bring the 10 behind the root sign. So you have 10 root 2. So that is the answer. The basic form of root 200 is 10 root 2. 10 root 2. So it's as easy as that. Getting the basic form, there's nothing hard. You can use the factor method, or if you can use this method or any other method, there are many methods one can actually apply. But you have to know your multiplication table. So if you're having any trouble with your multiplication table, make sure you have a good grasp of your multiplication table. So right now we've gotten the basic forms. So the next thing we're going to do is to go to the single forms. Like we move from 10 root 2 to root 100. How do we move from the basic form to the single form? So that is what we're going to do, from the basic form to the single form. So in the next lesson, that is what we'll be looking at in our next lesson, how to go from the basic form to the single form. So thank you so much for joining us in this lesson, and I believe you've actually enjoyed it. So
share with your friends, share with others, and to, as in, help us spread our video to a wider audience. Just don't hesitate to hit the subscribe button and the like button as well. And please drop your comments. If you know you enjoyed the video, drop your comments. If you know there are any ways we can actually improve, also drop your comments as well. And hit the bell icon so that you will always be notified whenever we upload a new video. Thank you so much, and bye.